In our first guided exercise, it says determine an antiderivative f of x, capital F of x equals x cubed plus 27. So an antiderivative just means provide one function that if you take the derivative, it will equal this value. So since this is a power rule, right, if we were taking the derivative, we can undo that by using the power rule for indefinite integrals. So we add 1 to the exponent, and we would get x to the 4th over 4, and the antiderivative of 27 is 27x. So I could just stop here. I don't need a c here because I don't want all the solutions, I just want one. I could say c is 0, and in fact you could put any constant you wanted at the end of this function, and if you took the derivative it would equal x cubed plus 27. But if we want to find all the derivatives of 3 over x, well, 3 over x is the same thing as saying 3 times 1 over x. So f of x is going to be 3 times the natural log of the absolute value of x plus c. So now for any value c someone picks, right, this is the general solution. I've got all the possible derivatives of 3 over x. Problem 3 says find the most general antiderivative of f of x equals cosine x. So once again, I need to make sure I have my constant of integration. So if we take the integral of cosine of x dx, well, the derivative of sine is cosine. So sine of x plus c. For number 4, we want to rewrite this a little bit so that way we can use a power rule all the way across here. So this is the same thing as the integral of x squared minus 7x plus x to the 1/2. So now if I anti-differentiate this, it's x cubed over 3 minus 7x squared over 2. X to the 1/2 plus 1 is x to the 3/2. And when I divide by 3/2, it's the same thing as multiplying by 2/3. And as long as you have your plus c, you're done. Number 5, we want to do something similar. I want to rewrite this as the integral of x to the negative 1/2, so I can use the power rule. So now when I anti-differentiate it, well, negative 1/2 plus 1 is positive 1/2, and when I divide by 1/2, it's the same thing as multiplying by 2, and then I add my plus c. Part B says, well, determine the antiderivative, so we want the unique solution if f of 0 equals pi. Well, I already know the antiderivative. I've already calculated it in part A. So f of x is 2x to the 1/2 plus c. However, I'm told that if I plug 0 in for x, so f of 0, right, that's 2 times 0 plus c, that all of that should equal pi. So the left side we can see of this equation is just going to be c, so c equals pi. But I'm not done with the problem until I rewrite the function plugging in my value for c. So now the unique solution to this particular problem is 2x to the 1/2 plus pi.